find an equation for the tangent line to the curve y equals 4 minus x squared at the point, I'll abbreviate point here, PT, 1, 3. Right, the eraser's not the greatest. Okay, so before we go on ahead and talk about rates of change and derivatives and tangents, when you want to find the equation of a line, what do we need? The slope, right? We already have a point. Otherwise, you would need to have 2 points, right? And then from there, find the slope and the intercept and all that. We have the function for which we want the tangent line at the point 1, 3. Right, so we have the point. What do we need to find there then?
Slope.
The slope, very good. Now remember that we said that the slope is the instantaneous rate of change, and we also call it the derivative. So, and we gave you the definition. We talked about the definition for the derivative. I'll put here slope and word. Slope at the point 1, 3 is m, which is going to be the derivative. I'm writing it in words, and I'll give you the notation here in a moment for derivative. The derivative at 1, 3 again. And remember, we defined that as the limit. There were 2 different ways in which we defined it, with the h going to 0, or with x approaching the point 1 here. So we could do that 2 different ways. The way I did this problem, I used this 0, so h approaching 0. Remember, 2 different ways, either, I'll write it here. Can you see that part? Limit as h goes to 0 of f of something, let's say a plus h minus f of a over h. That was one way. This is an h. But we also wrote it as limit as x goes to a of f of x minus f of a over x minus a. Remember, there were 2 ways to write that. Again, I'll give you the notation in a moment. For now, I'm just calling it m to emphasize that that's slope. That means slope of the tangent line. Okay, so the limit as h goes to 0, and we have that this function is y equal 4 minus x squared. To avoid confusion, let's call that f of x because I'm using that notation here. So every time we write y, you're going to interpret that as f of x. Again, because you see an f here, right? F of x plus h minus f of x over h. Let me see if I zoom in a little. Because it doesn't seem like it's too good there. Does that work at all? Does it help?
I do have one question.
Yes.
So on the first formula, is it a minus between the f of a plus h? It's also minus f.
Here,
Because the red line is
a plus h minus f of a.
Thank you.
Yeah. And then here to minus. Yeah, if you don't see that very clearly, always ask me. Okay, so the derivative of 1, 3, the derivative of what? The derivative of this function. And I'm writing the function as f of x. So let's use this form because that's the one that I used for this problem. So f of a here is 1. That's the value. It's gonna be 1 plus h minus f of 1 there, over h. Is that clear? Okay. So now we have to substitute like we've done in the past. We found limits like this before. As h goes to 0. And then let's put each piece of the puzzle together. We can't do anything with the h at the moment. We have to substitute. Let's look at the easy one. What's f of 1? You plug it in here, right? But they already gave it to us. 3. Huh? The 4 minus 1 squared, which is 3. We already had it, but it's good to verify that, so we have a minus 3 there. Now we worry about f of 1 plus h. Remember, like we talked about before, wherever you see an x, you're going to replace this. You're going to put 1 plus h wherever you see an x. And that x is squared, so that means that the 1 plus h part has to be squared. Remember, this is all algebra. We are not doing any calculus yet. So I have the 4 minus the quantity 1 plus h. So this 4 minus 1 plus h is f of 1 plus h. And then I have the minus 3, which is the f of 1, and then everything divided by h. All right. I still write the limit because I haven't done anything with the limit. Remember, we have to simplify because we have 0 over 0, right? If I plug in 0, I'm going to get the 3 minus 3 and then 0 in the denominator. We can't do anything with 0 over 0. You have to keep working. All right, so 4 minus, I'm going to FOIL this. 1 plus 2h plus h squared minus 3. And then I have an h in the denominator. And you want to simplify this stuff, obviously. So our goal is to get rid of that h in the denominator. So the 4 and the 3 give us 1. What? Thank you. So the 4 and the 3 you can cancel, that'll give you 1, right? And then the 1 there. And then I have a minus 1 plus 2h plus h squared. And then 4 minus 3 is 1, so I'll put the 1 there. Over h. And then the 1's cancel. And I have a minus 1 plus 2h plus h squared plus 1.
Shouldn't the subtraction sign go to all the terms in the
Yeah, should distribute that.
Oh, thank you. It's a minus there and minus there. Minus and minus. And so I have the limit as h goes to 0. I'm sorry if some of my h's look like n's. I'm trying to write fast and then it just looks like an n. The minus and then the minus, that still looks like a plus. My eraser's not looking that great. I'll put it here. This is a minus, and that's a minus right there. And these guys go away, and that's good because now we can factor. Let's factor a minus h. This went away, the minus 1, and the 1 went away. So on the top we have minus 2h and minus h squared, and then I have an h in the denominator. So let's factor a minus h. I end up with a 2 plus h divided by h. We don't apply the limit yet because again we still have 0 over 0. But because we factor the h, we can cancel them. H is not 0, right? It's just approaching 0. So we can cancel those guys. And then we simplify. I'm going to write that right here. Limit as h approaches 0. And I still have the minus sign, so minus 2 plus h. And then this is a polynomial in h. So it's a continuous function, we can always then plug in the 0. So the limit's going to be minus 2 plus 0, which is minus 2. Remember, 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 remember. Once I apply the limit, I don't have to write it anymore. I'm applying it right here when I plug in the 0. Remember, 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 remember that you always have to write the limit until you use it. And you write your expression as it is. This is exactly how you're going to show your work unless, so your other option is to write this right here, then somewhere else on your page, you just do your algebra, simplify, and you get minus 182 plus h. Once you get there, then go back here and do the limit of that expression. That way it saves you from the trouble of writing limit every single time, because you might forget. You see what I'm saying? The two different ways, and I'm okay with that. So you either do this, or once you get here, you write it down and then do your algebra somewhere over there that I can't see it because I'm gonna grade you on work. And then once you have the expression simplified, then you come here and apply the limit. So you are going to lose points if you don't do that. You're going to lose points if you don't do that. So
On the second step, where'd you get that 4 from?
From the, from a line.
This one, y equals 4 minus.
Oh, okay.
right, or minus 181 plus h.
Oh.
Now, are we done? Look at the question again. What is it asking us to do?
Find the tangent line to the curve.
Right, so we're not done yet. What is this minus 2?
Is in a point on the.
That's the slope.
It's just this slope, right? This whole thing is equal to m. M equal, negative 2. We have a point though, so we can find the equation of the line somehow. Tangent line. I'm gonna have to, let me use this other page here. And we can look at our work. The slope is minus 2, slope of the tangent line. And it's also the slope of the curve, but at this moment we care about the tangent line per se. At the point 1.
Just move the paper down.
What do I do with that slope?
You put it into the point slope formula.
So what does a point slope formula look like?
Y minus y squared. Equals m.
Oh, sorry, I thought you were saying slope intercept. Or let's do that one. You said point slope and I interpreted slope intercept. So we can do that one. You can still do slope intercept form and then solve for b. That's okay too, and I'm okay if you do that on the exam. So the slope is a negative 2, and then I have an x minus 1. Now the instructions said find an equation of the tangent. It didn't say find the equation in this form or that form. So I would accept this as an answer if the question says find an equation of the tangent line and it doesn't tell you which way to write it down. That just makes sense to you? So if I say write the equation of the tangent line in the form slope-intercept form, then yeah, you have to write it as y equals mx plus b. Otherwise, you can just leave it like this. So if you want it this way, if you want it the other way, then you would say, okay, y equals 3, so move the 3 to the other side, adding 3 on both sides, plus negative 2x, and then you have a minus 2 and a minus 1. And so you can write y equal minus 2x, and then I have a 2 here, so I have a 5. And you can also write this solution that way. Okay? So 2 different ways. I didn't tell you how to write it because the instructions said find an equation, not find the equation in this or that form. Right there, those were the instructions. Find an equation. Questions? The algebra is probably the biggest issue. And remembering from your algebra classes how to find the equation of a line. Right? Okay, let's